This has been a bit of a journey. There's been a lot of partners involved with this project. You see some of them here, some of our sponsors that help make this possible. Of course, today's technical session is really a prelude to the full day conference that we have tomorrow. Very much looking forward to it. I'm going to admit I am not a water expert by any means, and so my role is really to help things keep things going and to learn, to listen to those experts and see what we can do to ensure that we do have sustainable water resources in the Chihuahuan Desert. My secondary job is to introduce my boss, which is a little bit intimidating, I must say. You know, when we've had a lot of changes at the university, and the more recent changes have been for the better. I promise you that. When you ask what should a provost look like, or what kind of skill set a provost should have, you want somebody who's got some accounting background. You want somebody that appreciates what a university is, supports their faculty, and we have all of that in our current provost, Dr. Bernie Quintanez. So I'm going to welcome Bernie up here to the stage, and he has been extremely supportive of this effort today and kind of putting Sul Ross back on the map from a community standpoint. So please welcome Dr. Bernie Quintanez.
That was very gracious of you, Louis. I appreciate it. So it is my honor to be here today and to present our speakers. But before I do that, I want to say something about our role here in the university, why it's so important for us. I am not a water expert either. As Louis mentioned, I have an accounting background and I am a philosopher, so I'm very far away from the natural sciences. So my name is Bernie Quintanez, and as Louis mentioned, I'm the provost and the executive vice president of Sul Ross State University. So a university should provide a space for dialogue, debate, and open inquiry. It should provide a space where new ideas can be explored with honesty, respect for others, and a sincere desire for truth. A university is a place where knowledge and skills pass from one generation to the next, and where students are transformed into critical thinkers and informed citizens. It is an intellectual and creative incubator of future scientific discoveries and artistic productions. That's important because my daughter's in art history, so I gotta make sure I keep the arts in there. It is also part of a larger community of inquirers who conduct ongoing research, advancing knowledge, and expanding our understanding of life, nature, and the universe. As the provost of Sul Ross State University, one of my central responsibilities is to nurture and facilitate an academic environment and culture where areas of study, programs, and new lines of research and investigations such as this can emerge and flourish. Whether it be in political science, biology, anthropology, geology, psychology, it doesn't matter. The underlying principle is the same. How can we advance theoretical and applied knowledge with the objective of discovering truth, or at least coming closer to it, and advancing a more just world, while enhancing the quality of human life, future generations, and all living things. The opportunity to host and participate in the Water in the Desert Conference at Sul Ross epitomizes, in my view, what a university is supposed to do. It should be a leader in research and research methodology, providing scientific information on water sustainability from some of Texas's top water experts, as we have here today. It should be a leader in service to the community and the larger region, providing a forum for open dialogue and discussion on water sustainability issues among various stakeholders. It should be a leader in outreach, bridging different sectors of society that otherwise would not interact. In other words, connecting water activists, landowners, legislators, policymakers, and scientists on the important issue of water, sustainable future. And this is exactly what this conference does. The issue of water is critical. It is number 6 in the United Nations top sustainability development goals. Disease caused by contaminated water kill more people every year than all forms of violence, including war, which is an incredible fact that I did not know before I prepared these opening comments. Water is critical for living things, agriculture, meat production, clothes production, electricity, many other basic amenities that we all enjoy every day. If that doesn't convince you that water is important, it takes 20 gallons of water to produce 1 pint of beer. So the importance of water, coupled with the fact that we in Texas live in one of the driest areas of Texas and possibly in the U.S., sets the stage for an exciting and important conference. Today, we will hear from a team of experts led by our own Sul Ross's Dr. Kevin Urbanczyk, professor in the Department of Natural Science and director of the Rio Grande Research Center. We'll hear from Robert Mace. Dr. Mace is the executive director of the Meadows Center for Water and the Environment at Texas State University. And Jeff Bennett, who is habitat restoration hydrologist with Rio Grande Joint Venture. I thank you, I welcome you, and Dr. Urbanczyk.
I should say thank you to our sponsors. They're all up here. I'm just going to introduce the session real quick and then turn it over to Jeff. Just to give you a sense of where we're going this afternoon. So you're going to hear some presentations from each of us. Jeff's going to talk about hydrology of the Chihuahua Desert. I'm going to touch on the hydrogeology. These are just brief overviews. We could chat all day about this and into the night, provided we get that, what was it, 20 gallons, 20 quarts equivalent beverages in us. We could go all night talking about water. After that, we're going to hear from Dr. Urbanczyk to talk about water data and research needs in this region. We're also going to talk a little bit about kind of value of research centers, as well as some plans here at Sul Ross University. And then we're going to open it up to the audience. For questions, if you have questions, but perhaps more importantly is to hear what you think the data gaps are, the data needs are. And I would say even policy needs. If you're concerned about declining water levels, if you're concerned about declining spring flows, if you're worried about changes in rainfall, or how to capture flood flows.
Thanks for coming, everybody, and I appreciate the chance to talk to you. We split this up into hydrology and hydrogeology, which means I'm going to talk about the surface stuff, and Dr. Mace is going to talk about the underground stuff. But I hope at the end of this, you understand that separation is pretty fuzzy. So I'm going to start with precipitation, just to give everybody an understanding of how things have changed a little bit. The National Weather Service, or NOAA, released some new 30-year averages a couple of years ago, and I've got them highlighted here. I think we'll just focus in on a couple of averages here. Dryden lost 5.5 inches in their yearly average with these new 30-year normals, or 30-year averages. Fort Stockton lost 2 inches, almost 3.5, or more than 3.5 at Guadalupe National Park. Alpine lost 1 inch in annual precipitation. It's also getting warmer, so less precipitation is falling and it's hotter, so there's more pressure on that water to return to the atmosphere. I don't think that this can be underemphasized. There is just less water coming to us. I work with the Regional Water Planning Group, and one of the things that I wanted to point out was that they have recommended 9 stream segments. as ecologically significant for the state water plan. That means that if there's a project with state or federal funding that would flood that stream or damage that stream, then you have to say it out loud. This is not really, doesn't really offer any protection. And also notice that these are all associated with conservation land or public land. None of these are on private property. So there's 9 of them, and you can see how little private property there is out here. So if you multiply that by a factor related to the amount of private property versus public, the number of ecologically significant streams, and that what we're talking about there is perennial streams, is much greater than 9. One of the 20 years I've been back in Alpine, the trend that we're noticing is that all these stream segments are getting drier. Some have gone from perennial to ephemeral, or excuse me, intermittent. It means that they're only wet during monsoon season. They're dry the rest of the year. They might be a little wet in the winter. There's some seasonal stuff, but they are drier. So they're all groundwater supported. Every one of those ecologically significant stream segments are groundwater supported. They're tied directly to our aquifers. And again, some of these segments are no longer perennial. The water plan group has also identified a bunch of major springs. Some of them you might recognize, just outside of our district is San Solomon Spring, which is a big topic in this meeting. However, there are other big spring systems. There are some associated with the Sierra Vieja, you can see here. A lot in Big Bend National Park. There's many more on private land, and many of these, even on the public lands in the national park, they've been altered. Many have been altered, which means maybe water is easier to access, but maybe not good for wildlife or good for overall water management. They're probably evaporating more water because a lot of times we remove the trees around them, we dig them out, when there's more open water, there's just more evaporation. So they're drying out too. I'm going to talk a little bit about a trend in the Rio Grande. These lines here represent the total annual discharge. So the wider the line, the more water, right? So as we move down in the watershed, we have a wider line because there's more water. The catchment area is bigger, so there's just more water. The blue is the historic. The red is the current. So we've lost this much water. You double that because it's on both sides in the system. This trend is not unique to the Rio Grande. It's the same on the Pecos, you can see here. It's the same on the Devils. It's the same in our streams in general, because we built a lot of dirt tanks. This is all because of utilization, right? We build dams and reservoirs so we can use that water, but we've done the same on our smaller streams. There are thousands and thousands of dirt tanks out there. It means that water doesn't get to the stream. It sits in an upland where it's sealed off with silt, and probably most of that water evaporates or gets used to water livestock. Which, you know, that's a legitimate use, but there's the unintended consequence of that water not getting to a stream and recharging an aquifer or supporting riparian habitat like big cottonwood forests. Diminishing flows also plays a role in water quality. There's less water, there's more salts, basically. Some of you might have heard the adage that the engineers love to give us, that dilution is the solution to pollution. If you decrease the amount of water, the watershed's still making a lot of salt, still producing salt, so that salt becomes concentrated. So through time, I don't know if y'all can see these bottom graphs, but through time, we've got a rise in total dissolved solids. So that means that water is getting saltier, and it's less potable. It costs more money to use it because we have to treat it. So it's less favorable to the wildlife that use those waters. So TDS is increasing, and this is a trend that we see with other things besides just the salt concentration. It's also true for bacteria and other things like that. So many of the stream segments in our state are no longer, they're listed with EPA as not meeting standards. That's an easy report to look up online, and you will be astonished how long that report is, how many stream segments don't meet standards. Diminishing water also means that we have changing stream shapes and stream character. This is a picture of the Rio Grande at Johnson Ranch, at the gauge near Johnson Ranch in Big Bend National Park. It's looking upstream. So this is in 1945. You can see the river goes from bedrock to bedrock. It's super wide, very little, some sandbars here, but they're small and they're not vegetated because every monsoon season, enormous flush comes through and lifts all that sand up, spins it around and puts it back down, and there's no plants left. So big eddy, alternating sandbars. And then in 2008, you can see big steep sandy banks with, some of these are actually native plants, but there's a lot of salt cedar, and this over here is giant cane. So those habitats where fish and different things would depend upon to feed are now gone. So this becomes, from a nice big wide river with lots of diversity in habitat, in depth, water velocity, water temperature, to something more like an irrigation canal. Now we're going to spend a minute or two with this one. I want to, at the end of this, I hope you understand the role that groundwater can have in mitigating some of our challenges. This graph here, on the bottom, we have distance from the Gulf of Mexico. So as we're moving from left to right, we're getting closer to the Gulf. And here we have discharge. So this line, these two lines right here, as we move downstream, we have more and more flow. And that comes from groundwater, from lots of significant little spring complexes. So moving downstream, more and more fresh water coming in from the Edwards Trinity Aquifer. This line is described in this axis, which is what we call specific conductance, which is a surrogate for total dissolved solids, or how much salt is dissolved in the water. So as we move downstream, this line goes down because the water is getting fresher and fresher and fresher. It looks more and more like the groundwater. So that's a really important aspect of the way groundwater and surface water interacts. Finally, I'm just going to show one more graph here. This is annual flows out of the Rio Concho. So I'm sure most of you have seen the stories in the papers about water not coming from Mexico. But this is just one of the 5 tributaries that the treaty says they have to deliver water on. And these are the annual flows out of the Conchos, and you can see how low they've been. This is 2008. Some of you might remember the flooding in Presidio during 2008. This looks more like all the data before 1995, this particular bar, but it's been very, very low. And these 2 green lines are the estimates that Dr. Banzak and I and some of his students have come up for how much groundwater is contributed to the Rio Grande and to Amistad, to the reservoir. And you can see that most years the groundwater is more significant than the surface water out of Mexico. And I think that's it. Thank you.
All right, so I'm here to tell you a bit about the hydrogeology of the Chihuahuan Desert region. I didn't quite go to geek level 7 that Jeff did, so kind of more to provide an overview. Little bit about me, kind of what I know about the regions and informed through my career. I was involved in the early in my career doing hydrogeology for the low-level radioactive waste site that was proposed outside of Sierra Blanca. So I did a lot of kind of work in that bolson, some groundwater modeling. I then worked at the Water Development Board for about 20 years, and for a while ran the groundwater availability modeling program. So did some modeling work. I've got some great stories about kind of working on a model for the Presidio bolson. being mistaken for being a drug runner by the Border Patrol, but not for today. Later, when we're drinking those 20 quarts of water, yeah, in pint-sized. And then also with the state, kind of various things that have popped up in the region. I was at the Water Development Board when there was a proposal to pump water from the Presidio Bolson, put it into the Rio Grande and flow it downstream to other users. And then more recently, with my tenure at Texas State University, been doing quite a bit of work at Comanche Springs and better understanding that flow system, and then also looking at some of the policy aspects of how the science and the policy can be brought together to maybe create a situation that could bring those spring flows back. So Texas, the Water Development Board are the official decreers of the aquifers, named aquifers of Texas, and they divide the aquifers. There's really three categories. First is major aquifers, and to be a major aquifer, it's generally big water over a big area. And so there are three in the Chihuahuan Desert region of far west Texas. Hueco-Mesilla Bolsones, of course, a major supply for El Paso. There's the natural recharge there is only about 5,000 acre feet per year. Speaking of surface water groundwater interaction, all that water before groundwater production used to discharge to the Rio Grande. Now the Rio Grande is estimated to be losing probably 20 to 30,000 acre feet into the aquifer. And of course, that's a major supply for El Paso as well as Ciudad Juarez. There's brackish groundwater desal, so a lot of interesting things happening there. Pecos Valley alluvium, there's some agriculture out there, but a lot of that now is being produced for hydraulic fracking, a certain amount for frac sand mining as well. And then we've got the Edwards Trinity Plateau aquifer, limestones. That's where the Comanche Springs episodically issues from. I stopped in there on the way here yesterday. They're not flowing. They have been coming back during the winter months. There's agriculture, that aquifer is used for agriculture, municipal supply, and then also some supply for oil and gas industry. Then the second broad category for the board is minor aquifers, and which are one of two things, either big water over a small area or little water over a big area. Sometimes people get upset, my aquifer is major to me. It's like, yes it is. Calling it a minor aquifer is state's not insulting your aquifer. Just putting it into perspective with different aquifers, but this is where a lot of the action, hydrogeologic action, is in the Chihuahuan Desert out here. And so there's a Bone Spring Victoria Peak. It's a karst system, limestone. Water flows through it like a greased pig. The Capitan Reef Complex, which you can see, there's two arms of it here and actually loops up in New Mexico. Also, karst limestone, water often flows through it like a greased pig. We've got the Marathon Aquifer here around Marathon, Texas. Kind of hodgepodge geology. We've got the Igneous Aquifer here, which when I first started the board, it was kind of three pieces, and it was expanded. And then we got these Bolson aquifers, which are these valley fill aquifers that are kind of similar to Hueco-Mesilla Bolson, but they don't produce. I don't think they have the capability of producing as much water as the Hueco Bolson. In terms of some interesting things here, the El Paso, of course, has plans to desalt this water and transport it to El Paso. El Paso, I think, also has some holdings here in Capitan Reef. I can't recall if there's plans to pull that over in the state water plan, and I think also El Paso has some property down here. There's Midland and some other cities are looking to take water from the Comanche Springs area by Fort Stockton up. I already mentioned, there were some plans back in the day. It was a proposal working with the General Land Office from private landowners to lease groundwater from the state, pump it, dump it in the river, because the state doesn't have to abide by groundwater district rules. Jerry Patterson, who was the commissioner at that time, after a big uproar, agreed to follow groundwater district rules, but I don't think that's in law. And then, this whole area is just a lovely part of the state. I firmly believe if you don't love far west Texas, you're not really a Texan. And so, kind of similar to the hill country, I have a saying that we're loving it to death. I don't want to say that people are loving far west Texas to death, but it's a very popular place to come to. You'll hear from Kevin tomorrow morning, talk about some of the management issues with, say, a lot more bed and breakfasts popping up and more people moving in and potentially unregulated wells out there. Let's see, this is a slide showing Springs of Texas. This is a database that's out there. I'm doing a lot of research on Springs of Texas right now. Be careful with this data set. A lot of the locational information is not quite right, but it is a good indication of where a lot of the springs are. And you heard Jeff talk about the groundwater surface water connection, and a lot of that is facilitated through springs. And so you certainly see that there's a number of those out in the Chihuahuan Desert, creating these oases that we love. And there's probably more springs than are shown here out there. This is data from the Water Development Board. Water Development Board is just a wonderful place to find data and information. This is from their online water well database. And you can turn on something that shows you all wells that have been drilled if they followed state law and submitted paperwork with the state since 2001. And so you can see where a lot of, this isn't all existing wells, these are just wells since 2001, so you can see where a lot of wells have been drilled, and obviously over in the Pecos area, over the Pecos Valley alluvium with oil and gas exploration and fracking. There's a great number of wells that have been drilled up there. The urban, as well as the kind of rural irrigation area, because there hadn't been a whole lot of water coming down the Rio Grande. Jeff showed that map showing the relative flows, and I'd say they're probably even lower than that over the last 10 years.
It's a 10-year-old graph.
It's a 10-year-old graph, yeah. And then and you'll hear tomorrow, you'll hear Kevin, Dr. Banzig talk about kind of what's going on here. Here's kind of like, there's a whole lot of loving going on right here on the groundwater side. And then there's groundwater models. You're going to hear some talk later about groundwater models. So I just wanted to give a brief tutorial. This is basically scientists taking what they know about a groundwater system. We have flow equations that curiously look very similar mathematically to equations that describe the flow of electricity or the flow of heat. They go into these computer models that are then calibrated based on what we know. And then we hope we can use these models as management tools or perhaps as scientific interpretive tools to better understand these systems. When I started with the Water Development Board, I helped start this groundwater availability modeling program. And the legislature directed the Water Development Board to develop models for all the major and minor aquifers of the state. And so pretty close. I think they're like maybe down to 2. I think the Marathon is 1. The eastern arm of the Capitan Reef, there's a groundwater model for it, but not one for the western one. So there may be some suggestions that the board do something there. But it's kind of like the weather folks. They run a computer model to show what the weather's going to look like over the next week or so. Groundwater models are the same thing. And key pieces of information are the geology, the wells, and where the different rock layers are in the subsurface, spring flows, water levels in those wells, and how they're changing or not changing over time, water quality, the chemistry, are all valuable things that go into informing these groundwater tools. Somebody famous at some point, I think it was an economist, said all models are wrong, some are useful. They're wrong by definition because they're models trying to approximate reality. Reality tends to be far more complicated than what we can stick into a model. kind of like there probably are some non-useful models out there, but I think every model in exercise is useful. Sometimes you learn, I ain't doing that again. But you can use the models to help kind of test different theories or different hypotheses of how these systems work. A lot of the minor aquifers we don't have a lot of data on, just in general across the state, and that's particularly true in West Texas. So we certainly don't have the data we would want as hydrogeologists or groundwater modelers. And so I think, and Kevin will talk a bit more about data gaps coming up pretty quickly. And then the last slide I was going to put up was groundwater conservation districts. So I'm just going to dip my toes a little bit in the policy. Legislatures identify groundwater conservation districts as the preferred tool for managing groundwater resources in the state. And we have this foundation of the rule of capture, absolute ownership doctrine. And then groundwater districts can manage, be used to kind of manage and put rules on, maybe how much can be produced, well spacing. They also often kind of lead data collection efforts, or it can be intermediaries, say between scientists like myself and Jeff, to landowners, because most of Texas is owned by private landowners, and so scientists need access to collect the data. There isn't one out in El Paso County, although many years ago the state determined that there really needed to be one, but El Paso acts as a de facto manager of the system. They're the big dog in the county, and they're doing a lot of things to manage that resource, including working with their compatriots across the river in Mexico. All right, with that, turn it over to data and data gaps.
So I'm faculty here at Sul Ross and director of Riverend Research Center, but I'm also on the board of directors of the Brewster County Groundwater Conservation District. So I contribute some of my knowledge in that way. And I also work for the Presidio County Underground Water Conservation District. So I'm going to kind of mention a few of those things. So I thought I'd go back to that slide to start with that. So I'm going to talk a little bit about data and some data gaps and maybe some lack gaps. But I'm going to go back to the aquifer, the minor aquifers that Robert showed the map of. So, and by the way, I'd like to also say one thing. Throughout the development of the planning for this meeting, every time we have a meeting and they'd ask what do I want to talk about, I always say Brewster County. So I was very centric to where I live and where I contribute. So much of what I'm talking about really is going to be Brewster, Presidio County. And what's important to us in Alpine is the igneous aquifer. That's the red polygon on there. And that's the public water supply for Alpine, for Davis, for Marfa. And then also important is the Bolson aquifer, which would be water supply for Presidio. So there's that map again, and again to us the igneous aquifer is big. It's very important. It's under a new groundwater availability model. The GAM is under development currently, so we'll see how that might improve our understanding of the aquifer. But another thing, this is a Brewster County centric data gap. It's a little bit hard to point out, and let me see if I can, but which one's the
red one in the center?
red one? Oh, I see it, okay. So, right down here. So, we're loving Big Bend to death, like we've talked about. There's no aquifer, according to the Texas Water Development Board map of major and minor aquifers in the south part of Brewster County. Big Bend National Park is not in any aquifer except on the east side. There's a little bit of Edwards Trinity. And then otherwise the igneous aquifers mostly on the west side of the county and over in Presidio County. So there's been a lot of interest in the media recently about this loving Big Bend to death. There's a lot of people coming here to visit and or to move here. Is the increase in vacation rentals, is that having an impact on our water supply? Well, it's kind of hard to, there's no model from the Water Development Board at least, because there's not an aquifer. Clearly there is an aquifer in South Brewster County. In fact, the Brewster County, our rule set, our Brewster County Groundwater District rules mention namely the Santalina aquifer in South County. It's actually recognized by the district even though it's not recognized by the Texas Water Development Board. So I feel like it's important that maybe there's a data gap right there, is what is that as a resource? We know mostly the water quality over there, by the way, it's a Cretaceous karst aquifer in South County. The Santa Elena and Del Carmen formations really, it's in the Santa Elena. But the water quality is not very good. If you're familiar with Studi Butte, the Studi Butte Water Supply Corporation uses that water. They have to have reverse osmosis, a fairly costly process to purify that water. But then there is a public water supply. Lajitas does the same thing. The Studi Butte RV Park, I believe, has an RO. So anybody, any fresh water that's found down there in somewhat public, characterization has undergone some kind of a processing because of the water quality. Yet it's there. So there's a data gap, is that understanding what that aquifer is as a resource. Regarding districts, and I'm going to kind of double up today and tomorrow. Robert implied I was going to talk about this tomorrow, but just a couple of little quick things. The Brewster County District has recently, we have to come out with new rules because there were some things that came down from the state, but in addition to kind of boilerplate language of the new state regs, we did some modifications of our current rule sets to somewhat sort of address those concerns of the vacation rentals and or the increase in population in Brewster County. So basically, as it is now, you can, if you own 10 acres, here's kind of what Chapter 36 of State Water Code says. If you own 10 acres and you meet your spacing requirements, a few other things, then you're guaranteed, you don't need our permission. We ask for you to apply, but you don't need our permission because Chapter 36 of State Water Code says that. But if you have less than 10 acres or you're using the water for commercial purposes, then we created a new category that we call limited production. So if you want to do that, you don't have to pay the expense of a full production permit that a farmer or somebody that's going to use it for a rock crushing plant or something like that. So it's a more economically viable option. But what it does is it puts caps on what you can produce that are much less than what Chapter 36 says for your standard exempt 10 acres. So we've created this new category, and we think it's going to begin to address that because we put limits and we require metering. I think we're very proactive in that. And again, we'll talk a little bit more about that one tomorrow. Regarding the GAM, the groundwater availability models, we have desired future conditions. It's part of the way the structure of the process works. And those are desired future conditions. What is the drawdown do we expect in the future? What can we tolerate or what can we permit up to? The data gap for Brewster County is we have no litmus test to even come close to estimating what that is. Which well do we look at for that? I don't believe that well exists yet. Now if we move to Presidio County, Trey Gerfers is the president or the manager for the Presidio County Underground Water Conservation District, and he's been very active in securing funding to install monitor wells. So Trey has a whole sequence of wells, recently a big USGS grant to add to the National Groundwater Monitoring Program. So I can give him, I work for them, I'm the data manager, so I know a lot about this data. So I consider that to be a good model for Far West Texas anyway about monitoring. So what we do is we try our best to make this data available to the public. There's a commercial, the HAF company, it's the upper right one there. So there's a commercial publicly available data set that you can look at all of Presidio County's publicly available data. That's what that map is on the upper right. And then the USGS National Groundwater Monitoring Program has multiple wells in the data set there too. And I'm not leaving Texas Water Development Board out here on any purpose because they have a very similar interface that's publicly available also. But Presidio County has the USGS funding, so I'll put that in there. So here's an example real quickly. One of the things that I faced when I started going to work for Presidio County is they have real-time monitors. These devices are measuring water levels every day. And the technicians that were operating this were overwhelmed because they had 7 or 8 of these and somebody had to go typing all this data in that's coming in every day. And it wasn't very successful at that point. So what I've done in my sort of tenure there is just write a little Python code that just automates it. So every 2 weeks I query the devices. They're either sending data via a cellular signal or an Iridium satellite, all this weird kind of stuff with emails. but that's how the data come to us. And so every 2 weeks, I just kind of hit a button and make these graphs and send them out to Presidio County, and the well owners love it because they get to see what they're doing. And we as scientists get to start seeing trends and stuff. One of the things that's pretty clear on this map, or this sequence of graphs, is that all of these are pumped wells. And that's unfortunate. As groundwater monitoring, as you develop monitoring, it's better if you can find or have your own monitor well that's not pumped, but those are really hard if you don't have the funding to drill that well. So the well owners use these wells, and so that's mostly what you can see in those spikes downward. That middle one, the spikes upward, is when the power goes out and the pump stops. But anyway, there's all kinds of different things you can get out of this. But in general, you can actually see maybe this is only 2 years of data. This is just the data for Presidio County. The upper one shows a little decline. Maybe that's a bit concerning. We need this kind of long and increasingly longer term data to kind of feel like we know what the groundwater system is doing. And again, those are for Presidio County. We talked about Springs a little bit. The one thing I want to say about Springs, and again, this is Brewster County, very Brewster County specific, is this map of Springs is from the Region E water plan. And it, like the other one that Robert showed, the Springs of Texas, does not show any springs over there where that red circle is. And that's one of my favorite places in the world, where Jeff showed some graphs of that area. I will say Region E does have language in there, and I think it's something that I put in the Brewster County management plan, but the springs are mentioned in there, but the maps never show them. And these are the largest springs in Brewster County. They're the main source of the water that Jeff showed in those graphs that exceed the annual flow of the Rio Conchos. It's almost all right in there. It starts in Black Gap Wildlife Management Area and ends south of Dryden. But all of the big springs are in Brewster County. And they're mostly unrecognized. And one of the reasons is they're very hard to get to. So they're very remote and rural. Looks like that. It's a beautiful place out there in the lower canyons of the Rio Grande Wild and Scenic. So that's not so much a data gap, it may be an understanding gap of the presence of those springs. And again, I consider them to be for Brewster County at least, the largest volume of springs, and a main reason that the water quality in the Rio Grande improves through that stretch. So Robert, that is the end for that.
Awesome.
Thank you.
And, we'll block for. Oh yeah, it reminded me that the third category of aquifers is other aquifer, which would include Santa Elena. There is a process to add aquifer, to become a named aquifer with the Water Development Board. So that's something to investigate.
I know you and I talked about that, and the pros and cons, I think you pointed out, is that if it's recognized, then somebody can target it. That was one of the
Yeah,
concerns
but
you had.
you just let the cat out of the bag. You just. Yeah. If an aquifer gets named, then it becomes something that gets planned for. So it'll show up as a source of water in the water plan. So.
And that's not the only one, there's a couple
Yes.
more.
Oh yes. Yeah, it's like you can almost anywhere you drill in Texas, you can find groundwater. It's just a question of like how much and what's the quality. So that's why that's kind of say there's other aquifers out there. for
Right,
sure.
and I get the question often because people look at those maps and they ask, is there groundwater in South Brewster County? And clearly there is. And it's somewhat misleading in a way that there's not an aquifer on the map. But
Can you go a little bit more into those desired future conditions, especially like maybe compare igneous with the Marathon aquifer and
no.
is it not true that it's all planned depletion, right? We are looking to save the last half for the last 50 years,
Right.
but the reality is
It's a target.
yeah.
I'm joking when I say no, but I really don't really understand it very well. But what my knowledge of it is from the perspective of Brewster County Groundwater District is none of us have a clue of how we're tracking that.
Sure.
We have absolutely no idea. And that's why I want to implement something like Trey has got going in Presidio County, add to the Water Development Board that's already doing some monitoring in Brewster County. But we just need more information. That's a really big deal.
And if you're not familiar, a desired future condition is a policy goal like groundwater districts that share an aquifer, have authority over an aquifer, come together and define what their management goal is. So it may be spring-based, so like Barton Springs in Austin. There's the Barton Springs Edwards Aquifer Conservation Districts. They pretty much have the entire district under their authority. And their desired future condition is something like flow not going below 7.5 cubic feet per second. A lot of the desired future conditions are water, like kind of water level declines.
Right.
So it's a planned depletion of the aquifer.
But, I forget what county Menard is in, but, those counties in that area, they've written their desired future conditions to be protective of their stream flow. So not just springs. And that's something that, we need to recognize that a lot of our springs come up in streams. And so even though we got them in two different maps, they're really the same. But there are desired future conditions that are protected by that stream flow. Because those are important for those, those ag properties.
Kevin, it's pretty cool that you're a scientist serving on the board of the Groundwater Conservation District. What is that? I mean, it's hard to divorce policy from water.
Right.
When you talk about water, it's needed for everything we need to do. But I'm wondering what you've learned from that process as a scientist.
Well, I feel like I've contributed. That was my primary reason to do it. Because the other members of the board, they're landowners, they're retired people, whatever. There's no one else in science, and our manager is not, right now, she's great, but she's not knowledgeable in groundwater.
You're like a free consultant.
I'm a free consultant, that's exactly what it is. But I don't know, I can just only say that I'm trying to contribute. And I feel like it was my motivation that got us to add that new category. I really wanted to see that. People were asking, with all the vacation rentals and the popularity of Big Bend, are we loving it to death? And I think we ought, as the groundwater district, we ought to be looking at that. And we had always, you and I have talked about this, chapter 36, the 10-acre exempt well is a unrealistic, the production limits on your 10 acres from the state water code is unrealistic. 25,000 gallons a day is what you get for your 10 acres if all you're using it for is your use and your livestock. And that's a ridiculous amount of money, and we did the math on it. It's 100 times the average recharge over the same area. It's just unrealistic. So we needed a way to at least maybe put limits on the commercial use of that. And or what we're seeing also in Brewster County is 10 acres being chopped into 2 5s or more. So people are subdividing. And everybody that has their now 2 acres wants to put their well in. So now there's that many more going in. So we just wanted to start feeling like we could put some limits on that.
And it's a similar issue in the Trinity Aquifer in the Hill Country, where the exempt wells are, it's like death by 1,000 paper cuts.
Because there's so many of them.
There's so many
Yeah,
of them,
right.
yeah.
And that's a big number.
So have you identified any like other data needs, say being a board member of a groundwater district, or other data needs that you're seeing in your role as a professor here?
Well, I would say, from the perspective of the board, more wells for monitoring, because we can't afford drilling our own, and we've had a hard time, and maybe it's because we haven't really reached out well enough yet.
You need funding for that, right?
Well, we need funding, but if somebody's got ideally an unused well, then all we need is permission to go in there and put an instrument in there. What Trey has going there with the real time is kind of expensive, and Presidio County is even kind of pulling back on that, just putting loggers in there. But at least from those, we'll get that continuous, at least daily data. Brewster County's got a few of them, but we really haven't gone to the level of really making them work. But part of the reason is we are having a hard time finding people who will allow us to put them into this.
Yeah, that's a way that the citizens can help
Yes.
by allowing that access. And I guess as a citizen, you kind of know, you'll know what's happening with your
Yeah.
resource. You know, if the levels are continuing to go down, then, you know, maybe the next question is okay, when do I need to start worrying about my water supply? Or maybe they're flat and they go down in the future.
You won't know unless you have that data.
And it seems bonkers. I teach a groundwater course at Texas State University, and I tell my students, I'm like, it seems bonkers, just collecting water levels in a well over time, over an area can tell you so much about an aquifer, like which direction the water's flowing and coming from, you know, what the changes are with time, how it's responding or not responding to drought, which tells you something about the flow system.
When I first went back to West Texas, I was collecting water levels for the GAN. I think that's where we met, actually. But one of the things my job was to cold call people and just ask to come get data. And most of the times it was just click. But if I got to talk to them, one of the things I would say was, you know, if you haven't measured it, written down and described it, you don't have it. You have no recourse to say, well, my neighbor harmed me, even though that's legal in the state and you don't have a legal recourse. But you really can't even state it without having some public record of that water level. So again, it's not just how citizens can help, but it's also you get something in return from that documentation.
Yeah, that's true. Yeah, it's like you don't want to be, as a landowner, you don't want to be in this situation where, and I've seen this happen time and time again with similar folks, where it's like, nope, I don't want anybody collecting data. And then all of a sudden, next door goes a big pumper. And there's no historical data. Yeah, there's no historical information to show exactly how they've impacted.
Right, and that's one of the problems Brewster County has, and probably, I would assume other districts, but currently, as far as those production permits, Brewster County's got 5. And 2 farmers in Sunny Glen, 1 rock crushing plant north of town, the pipeline, whatever the pipeline still has theirs, even though they're not using it, and then there's 1 new subdivision. But there's a lot of other commercial use of groundwater, and we're not pointing any fingers. We'd love to grandfather all these in, we want the data. But if you are wanting to drill a well for commercial production permits, farming or whatever, you do have to follow you're supposed to anyway, the process. But we have a lot of use of water in Brewster County that we don't know about.
It's just not documented.
It's not
because
documented.
it's basically a secret.
Yeah, and there's a lot of that. Again, we're not pointing fingers, because on the board are people who have lived here all their lives. Everybody knows everybody. They know who it is. It's just, okay, why don't you, and we are very willing to grandfather them in with little or no fees to get them listed as production permits. And the cost for using water commercially in Brewster County is so small, it's so tiny that we're not using it as an income source.
In a sense, it's like your checkbook, right? You
Yeah.
want to know how much is going in,
Right.
how much is coming out, and those 2 numbers together tell you how much is there.
Yeah,
What's in your savings account or whatever. And we don't have those
we
numbers.
don't have that.
And there's a need for that information across the whole region. I showed the aquifers up there as kind of like discrete introverted entities, as if they live in their own little worlds, but they're partiers. They're extroverted. They're interacting with each other, very, very much interconnected. And so it's kind of one of the gaps is like, how are these aquifers flowing into each other? How does management, and it might even be outside the district, affecting resources in the district, or outside the county, in the county, or outside the aquifer? The aquifer next door might be something happening there that then is being reflected later downstream, if
Yeah,
you
because
will.
the districts are arbitrary county boundaries, not aquifers. But that leads to something that I tell my students, the wonderful diversity of West Texas geology, which is fascinating. That's why a lot of people come out here. It produces a very diverse system of aquifers too. And if you look just at the igneous aquifer, my background is volcanic stratigraphy and petrology. I understand the volcanic system out here, and it's a lot of inter and or not connected volcanic systems. So the igneous aquifer itself is considered an entity, but it's not connected in places. It's completely North County, South County, that's not the same
Or
aquifer, really.
Presidio County
For
to
Presidio.
Orister County.
Yeah.
And we've talked about the potential interaction between the Marathon Aquifer and the Edwards Plateau, Edwards Trinity Plateau Aquifer, and those springs that he was talking about, the graph I showed you, and then he showed you the circle. Are they connected? We don't know.
We don't know.
Is TWDB in the house?
Cody's back
Cody,
there.
is Cody here? Yeah, talk to Cody, man, he can get
Yeah.
those springs in the database, right, Cody?
Yeah,
He may require to go on a boat ride with you.
1 month from now.
1 month from now, you hear that, Cody? Okay, well, I think I'm up next. Oh,
Yeah.
I'm sorry. you got
No,
one
I
point?
was just pointing this.
Oh, it's up,
Yeah.
thank you.
Yeah.
Yeah, so I just wanted to talk briefly about research centers at universities. And so I happen to run this one at Texas State University. This is going to sound like a commercial for the Meadows Center. I don't intend it to be. I know that there's talk about creating something like this here at Sul Ross, so I wanted to share from my perspective some of the benefits of a group like this. And so, again, this is affiliated with Texas State University. We are on the university's property. It was created by the university after Andy Sampson left Texas Parks and Wildlife Department. Some of you probably know Andy Sampson. And so, and it's been under different names. I think it started off as a Texas River Systems Institute. So it was more focused on the surface water side of things. And then with time, about 10 years ago, through a big gift from the Meadows Foundation, and I think the Meadows Foundation might be here.
They'll be here later.
Oh, they'll be here later. Okay, good. I can say whatever I want then. They made a big gift to the Meadows Center, and then it got their name, and the name broadened a bit for water in the environment. We act as our own entity, so we're not attached to a department on campus. Sometimes they are, so the Bureau of Economic Geology is also a research center at the University of Texas. When I was there, it was not connected to a department. Now it is connected to its department, so there are different models there. We're not connected to a department. There's a little, it's a little bit of ongoing operations funding that pays a large part of my salary and a large part of my budget officer's salary, but then everything else is called soft money. So the money from the university is hard money, and the soft money is basically us going out and getting research contracts, whether it's through philanthropic groups, through local, regional, or state or federal governments, or contested opportunities to do research. We're focused on, which appeals to me personally, but we're focused on what we call applied research. So, we're not locked in the back rooms, never seeing daylight. Close the door. We're out working with the community, identifying problems that need to be solved, and then working to provide, in our case, the science. I'm a scientist, but when I was at the state, dealt with the legislature a lot, dealt with a lot of policy, and so there's also, those tend to be that kind of, when you start doing things to benefit people, the policy component comes in. You probably can't see it, but our mission is inspiring research and leadership that ensures clean, abundant water for the environment and all humanity. And we don't advocate, because we are a university research center, so we don't advocate on policy, but we do policy research. For example, bringing the science to help identify policy options. So it's sort of like, if you want to keep springs flowing, then here's some things you need to think about, or some things that you can do to do that. If you want to do this, if you want to do that. Sometimes that's governed by the funding source. So if there's a philanthropic donor that's very concerned about water quality in a creek, then we're doing research to understand what's going on in that creek, and then understand what's affecting it's water quality. And then it becomes a, piece of information to then help inform policymaker decisions. But again, don't advocate. One thing that we're fortunate with kind of the way we do our business is we've got about 24 full-time folks. We employ a huge number of students, in large part. Many of them are associated with educational programs with the glass bottom boats that you see there on Spring Lake at San Marcos Springs. You can't do that at Coconut Springs. I looked. Doesn't look like it's floating quite a while. But we also employ a lot of students in our research projects. So there's that educational component in there, and giving students kind of hands-on expertise on research projects and working with communities. And then also we're fortunate, we're 21 years old now, but we've got some endowments set up. A lot of those are due to the Meadows Foundation that allow us to support students through research. And the way that's kind of benefited me, because I'm also 1/4 professor in the geography department, and I have graduate students, is that I don't have to write a grant proposal to go do work on something. So say, for example, I got a student who just finished looking at the potential for rainwater harvesting across the state of Texas. Because I had endowment funds to support that student, and the student was interested in rainwater harvesting, we could go do that. That is research that then I think also potentially has some policy implications and applications. So those endowments help a great deal as well. And then we also serve as an integrator of talent, and so we're not doing everything in-house. So we're reaching out and collaborating with professors on campus at Texas State, but also with universities across the state and the country. And then also, if we need to, with private companies. So if we can kind of bring the different parties together, the best team, if you will, together to then go work and study a problem to then offer up potential solutions for policymakers to make. Any questions?
Well, not really questions.
Okay.
They may come up,
Okay.
but the parallel or the center that I'm working with, we already have the Rio Grande Research Center. And I had the good fortune of starting that with Andy Sansom, working for 10 years in 2004 to 14, roughly. And that had USDA funding, and that has sort of dwindled or completely dwindled. I've had other funding for it. But what our university administration is wanting is to sort of reboot it into something a little bit bigger. Maybe take the word Rio Grande away from it because it's geographically confining to, in a way. And it's supposed to become a center that incorporates sort of all the natural sciences and so else, I guess would be a way to put it. Biology and geology, and that's great. So, what we're wrestling with, it'll still have, because I'm the main person, at least so far, involved, it'll still be primarily a water focus. But we need a couple of things. I need language for a mission and a vision, which I have, but I need a name. And what because Rio Grande Research Center is going to go away, it's going to become what? And terms like, when you're studying hydrogeology or surface water in Big Bend, it's international. So, and all of our maps show nothing in Mexico, but much of the work Jeff and I have been doing for decades is with Mexican colleagues. So could I incorporate a name that has some international component? Well, Borderlands is already taken by the BRI at Sul Ross, Borderlands Research Institute. Great name, but that one's not available. Big Bend would be awesome, because everybody loves Big Bend, but we already have a Center for Big Bend Studies.
And it's more geographically
It
confining
is.
than
Then there's the Chihuahuan Desert, maybe that, but we already have one of those, Chihuahuan Desert Research Institute. So finding this name has been really elusive. What is, and I'm asking, anybody has ideas, I'd love to hear what you think this center's name should be, as opposed to just the Sul Ross Center for Science or something like that. And then, you know, my language is already, it's a bulleted sort of white paper that we've been distributing here, and I'm guilty for not having finished it out, but I think it's better that we maybe get feedback from people in this audience about, you know, what that center could be named, could be, you know, what could be the focus. We already kind of feel like we know that, but it's going to be more interdisciplinary than what RGRC, or Rio Grande Research Center, had been. But then that's also going to depend a bit upon the funding that we find and whatever. But of course, that's another part that we will also have to find funding to support this.
I think it's a missed opportunity to sort of pull it away from water, and I'm going to give you just a minute here to explain this. If you look at vegetation distribution throughout the Chihuahuan Desert, it's related to water. If you look at animal distribution, it's related to water. 70% of all the birds in the Chihuahuan Desert utilize riparian habitats at some point during the year. So the idea that we wouldn't have a desert university without a center focused on water is, I view it as a missed opportunity. I understand we want to include everybody else, but chemists need to be involved with water. The physicists can find projects in water, the biologists, everybody. So I just want to vote for rethinking that, move away from the idea that it's a water center.
Okay, well, with that, kind of want to open it up to the audience. Again, questions, data gaps, names for this research center. That's what we want. I vote for Bob. I think you should just name it Bob. Oh, here we go. Mike. Is anybody in charge of the mic? No, still on.
Not on yet?
Oh, there it is.
Okay, we have a microphone.
Sounds like AM radio.
Somebody's back.
Trans-Pecos taken?
Trans-Pecos is not taken, and along that same thought process, Far West Texas is not taken either. So either one of those is a little bit less regionally confining.
Here we go. We got a gentleman here. Oh yeah, if you could tell us your name, that'd be cool. Unless you want to stay anonymous.
My name is Steve Nelly. My question is back to the sort of the science. Are there estimates, is there a range of estimates of what percentage of annual rainfall makes it into the recharge, makes it into the aquifers? Is that information available? And I know it's different by aquifer, but is that information available, and what are some of those percentages?
I worked on a project with Steve, disappeared, but with Shoemaker Associates, and it was less than 5%. This was northern Culberson County, and I know you've worked a great deal with it too, but it's low. And that's 5% of rainfall, less than.
Yeah, it sounds, in general, with aquifers, 4% is my knee-jerk number. It's probably even, it could even be 1%.
Yes,
Because
1%.
Yeah, we looked at that because the report that he's talking about was part of that GAM from 2002. And it's divided up by basin, so it actually takes into account the surface topography. But those numbers were 1 or 2%. And that's where we came up with that, comparing to chapter 36 and that 25,000 gallons. That's 100 times more per acre than the estimated distributed recharge.
And that goes back to what he said earlier about everything being oversimplified, because in a normal year, 12 inches of rain in Alpine, there's probably very little recharge. You need to have an 18-inch rainfall year or more to actually get water into the, significant water, back up to that 4% or 3%, whatever.
Yeah, the overall water budget for Texas, for every 100 gallons that falls out of the sky, 86 of it goes right back up through evapotranspiration. So plant sweat and just simple evaporation. So if you're thinking that's a crazy low number, I mean, most of the water that falls out of the sky, and more of it
probably more than 86% out here is going back up to the atmosphere pretty quickly.
That's correct. The evapotranspiration rate for Alpine, I think I looked up, is like 50 inches, 40 to 50 inches a year.
So we got somebody back here and then we got someone right up front.
I'm Ruthie Russell, and this may be a question more for Steve Melly, but I've always had, there's a conundrum when you're wanting to restore small springs on your ranch, and you have trees around that spring, which on the one hand might prevent some evaporation through shade, but on the other hand, they're using the water from the spring. So if you're trying to restore and encourage that stream, how do you know how much brush or trees or whatever to eliminate from around the spring? Or should you actually try and leave the shade? We actually had a tank, and we went in there and cleared a lot of the brush around the tank, and we started getting a lot of evaporation we didn't have before. And I've been expecting it to improve.
It's not just shade you're looking for, it's also protection from wind.
Right.
You know, and there is no systematic difference across vegetation communities in evapotranspiration rates. I just looked this up. And yes, you can point to some deep-rooted phreatophytes or mesquite, basically, and complain about how much water they use, but cutting down your trees will not make more water. Vegetation management projects in general don't make more water. We learned that on the Pecos, we learned it on the Rio Grande, we've learned it in a lot of places. That's not to say you shouldn't manage your vegetation and maybe remove a few trees, because they do take up water, but cutting down trees won't make more water. I would suggest that your brush management project, I'm surprised that just managing brush, because this was mesquite and shorter stuff.
A lot of it depends on where you are, whether you're in the hill country or
Right,
out here. But specifically out here, this particular spring that we worry about, that we're going to try and do something that has a lot of dead trees. For instance, there was a fire that went through there, but it has a lot of huge cedar trees. And then it has a few, not poplar trees, and someone planted. But anyway, the spring, this rail come and go, obviously, like lots of springs out here, but it used to be a beautiful spring. It might be called Sheep Creek on the map.
Yeah.
It's in, Brewster County, obviously.
I think you should be very, very careful. This is really site-specific. Every little stream, every little spring is different, and just be very careful. And, talk to a number of people, whether it's the local biologist from Texas Parks and Wildlife, or somebody like me from a nonprofit, or someone like Steve. Just get a lot of opinions and go slow.
I'm Madge Lindsay. I'm with Trans-Pecos Bird Conservation. One of the things that we have done, and Cecilia and I worked on, is a book about water. We're doing it mainly for the conservation of birds, because that's one of the most important resources that they need. But I'm just so focused on all of these streams. When we do get a huge rain, instead of the streams being a source of putting recharge back into the aquifer, that the water just rips on out. And one of the things that we recommend, and I know Robert Potts has put it into effect, is the beaver dam analogs, where you put the brush or whatever in and secure it so that the water stops long enough that some of it can recharge. And is there any plan to work on any of the streams and say like Olympia Creek to take care of this water and push it into the aquifer?
You just made Jeff's day.
Yeah. I could talk about this all afternoon. I wish, had the time to show you some slides. On Friday, we're going to see Robert's place as part of the field trip. And we call them brush beavers out here, because when you say beaver dam analog, people focus on beaver and the conversation goes in weird places. But just because they're not, people don't think of them here, but we know that they were all up and down Terlingo Creek. beavers were here. But you're right, that, we overgrazed this country, heavy grazing pressure. We logged the streams, so there was more water coming from the uplands. There was less forest to slow that water down, so those flows in the, 100 years ago just ripped through those floodplains and channelized them. So when they do flow, you're right, they just rip on through. They don't get up on the floodplain. They don't get stored in the floodplain. So there are things to do. We can manage vegetation. Every one of our projects includes some sort of planting of a tree or, mostly cottonwoods and willows. We've got a source for cottonwoods and willows in Presidio where we planted 200 trees 5 years ago, 6 years ago. But vegetation management alone, in my opinion, is not enough. We've been doing it for 20 years out here and the streams are still dominated by erosion. So these structures that, filter dams of some kind, brush weirs, one rock dams away from the main channel maybe, those kinds of things do catch sediment and they do improve things. And those of you, we still have spots on our Friday field trip if anybody's interested in coming with us. We're going to go look at Las Ciénegas outside of Fort Davis and Robert and Lana Potts, this property. And we plan to put more out there. And yes, there's funding from a number of different funding sources that we can do quite a few more. So if you know of a place that needs some attention, we'd love to come look at it and make some evaluation of whether that's an appropriate tool or not. There's a lot of tools. The filter dams is one of them.
My name's Robert Potts. I know you don't have enough information to answer this question definitively, but I'd be interested if, based on the information you do have, do you think, given the amount of water that's currently being used and the amount of people we have here, that we have enough water for us 50 years from now?
As long as you don't mind planned depletion, probably for 50 years. I think I kind of divide aquifers into those that are very responsive to the weather / climate versus those that aren't. And so like the Pecos Valley alluvium isn't terribly responsive to the climate. There's a great deal of water in storage. We're already mining it. Probably 50 years, probably okay.
I don't know, I would add what I mentioned about Brewster County District, a gradual transition into a more conservation mindset. So that would reduce the demand on this increasingly less available water. I don't know, I feel like that's an important part of the equation also.
And I would say that at some point the chickens are going to come home to roost and there's going to be some real changes that people are going to have to make. We're going to not be left with a choice. And whether that's 50 years from now or 10 years from now, I don't know. But talk to the people on the Ogallala. Some of those folks are already walking away from their properties.
The pressure's coming from the other side too, so that information that Jeff showed with drying up of the climate out here, that's not good for recharge. So we're probably going to see less water coming into these aquifers to support current use, let alone the growth and use in spring flow.
Thanks for all the information. I'm Rebecca Smith with the Bureau of Economic Geology. We're a research organization at UT and we function as the State Geological Survey. And since about 2018, we've been doing studies trying to nail down the source of water coming into the Balmorhea Springs. And I just wanted to say, these guys have made some really good points, especially about, how to answer these questions. Oh, thank you. Yeah, thanks. How to answer questions like people are asking, do we have enough water? We need data. We need data to answer these questions. So Robert, I think, mentioned, maybe one of the others, about measuring water levels in wells and how important that is. The example Robert used was, okay, people don't want outsiders on their property measuring their water, but if someone maybe next door starts drilling a well that pumps a whole lot of water and makes the neighbor's well go dry, wouldn't it be better to have data, to show that there used to be water before this new well went in? And that's just one example. So if anyone could volunteer to either measure a water level in their well and share the data with us, or allow some of us to get on your property and measure water levels, I think it would help the whole system. So, thank you.
I've got one last question for the audience. Who won the crazy sock contest? What do you got underneath?
I bailed out.
You bailed out? Oh, looks like we got one more question. So we're gonna keep going until,
We have a lot of them over here.
okay, we'll keep going until Dan asks us to get off the stage.
Thank you so much. I'm Elaine Magruder from Midland, a landowner. That there's a couple of things that you touched on, and that's water collection. Being in Midland, I live on a farm, and I do water collection off a very small part of my roof. I use that. I have 4,000 gallons at the house, and I'm able to use that for all my gardens, all my flower beds. I have a system where if we run out of water in Midland, I can actually drink that water. I know that across the state, this is a hotbed subject because we're different in different parts of the state. And so, this is my first comment, and I have a follow-up. Tell me what your all's views are for out here for water catchment and for keeping it from going back into the groundwater. Because we don't see our groundwater for 50 years. Up where I am, it's Playa Lakes that recharge the overload. And it takes 50 years for that recharge to happen.
Well, I'm going to answer that partly and let Robert follow up, but I have a lot of friends in South County that live strictly off of water catchment. That's that conservation mindset. If you are frugal with your water, you can get by on what you catch off your roof. Now, that doesn't allow you to do a whole lot with that, but it's enough. So I think it's a great alternative. And in fact, again, because groundwater in South County is not very good quality, it's not really potable unless you have some processing to do. And if you're not on that water supply, you're left with water catchment, and a lot of people do it. I think it's great.
And the reason there's so much growth in South County is because they built the water supply system. When you had to haul water because the well you spent a lot of money drilling was dry, it kept the community small. And once they built that water system, it's grown, and people aren't being conservative with their water like they used to be. And that goes back to, we're going to learn some hard lessons pretty soon, I think.
We're already learning hard lessons, and I did a water budget, and I had a boarding stable with horses, and I was able to supply my water for my horses for a year without
Good for
using
you.
well
Awesome.
water. I want to do a follow-up on
Before you
Yeah,
do that,
sure.
So the Meadows Center, so this is one of the things that can come out of the center. Meadows Center will have a report that comes out later this spring that's going to provide a tool for folks in Texas to appropriately size a system that can provide a firm level of use. So in other words, based on the historic record, here's how big your roof needs to be, how big your tank needs to be, and what your use needs to be in order to have a reliable supply through the drought record. And a lot of people think rainwater harvesting by definition is not reliable. And what we're showing is it just depends on the system that you design and how you're using that water. And even El Paso, you could do rainwater harvesting in El Paso for a family of 3.
Or Chilingua.
Or Chilingua, yeah. I mean, so it's just do you want to do it? Properly design the system. So we're going to try to change the dialogue on rainwater harvesting. And that is, the state in the past has offered that up as a tool for controlling groundwater declines in the hill country. The hill country does have a very active rainwater harvesting community, but it's not active enough to deal with the groundwater issues. So you made my day by asking that question, by the way.
Right, well, unfortunately, some counties want to go in and do ad valorem taxes on ground, on that kind of.
I think they're exempt,
I hope it's
actually.
failed.
I think state law doesn't allow those to be
That's
taxed.
correct.
Yes, that's
Okay.
correct,
That is correct.
but they were trying to make a shift in that.
Okay.
I want to follow up on a whole different thing. I'm a landowner in Hector Andrews in Winkler County. I'm doing a water evaluation on our ranch, and I appreciate the comment and this follow-up comment about understanding your water levels in your water wells. And I think that is a key, but also there's a real key to understanding these different aquifers, and we have 4 aquifers on our ranch. And, I think if more landowners could go in now and evaluate what their water is and where it's coming from, what those aquifers look like. We have, we can start doing research that gets us ahead in that 50 years.
Cool. And I think there's another part to your question. If you're capturing rainwater, do you need to feel guilty about stealing recharge? No, you don't have to. It's such a small percentage that it's minuscule and unmeasurable.
Okay, so we got one more, I think this is back here, but one more, then, folks will still be around up here for conversations after they get staged, especially if you offer them beer. But, one more.
Willie Simmons. I live outside of Vanderbilt, and I do rainwater harvesting. For myself, I have 8,000 gallon tanks, and stuff like that. And I'm the only person that doesn't go in town and haul water back.
Didn't hear that last part. Yeah, so you're on you do rainwater harvesting, 8,000 gallons.
Okay. I'm the only person in town, or out of town actually, because I live 15 miles away from Vanderbilt. It's too crowded. I've got 8,000 gallon capacity for me.
Awesome. Yeah. Well, I love the rainwater people, so, yeah.
Okay, we're actually out of time. We're out of time. Okay, one more.
Can I just do one more, because it's going to cover like all of this. I'm Melissa with Texas Parks and Wildlife, and this is not just a shameless plug for our Texas Water Specialist webinars, because I'm going to start over here, because climate change, Dr. Mays spoke last year, and all of our webinars are recorded. So he spoke about climate change and water. Jeff will be speaking in June, rainwater harvesting with Dr. Mays, and that's going to be August 14th. June, Jeff, we haven't decided on a date yet, so it says to be determined. We have landscaping for bird habitat and riparian habitats, so that covers that. Marty Kelly right here, he talked about water monitoring data resources. They're all recorded. Go back and watch all of them. So everything that you guys have asked is in one of our Texas Waters webinars. If you want something presented, come to me and we'll present it too.
Awesome, thank you. Is that it? Oh, it looks like the boss is coming up on stage. You closing us
It's
out?
not me. It didn't flicker though.
It's up there.
So one last thing, kick off tomorrow morning early. Got a full day of sessions starting, but we do start with breakfast. So breakfast in the morning, registration, got Dr. Carlos Hernandez, President, Sol Ross speaking, got a great keynote speaker at lunch, or right around lunch, but great panels all through the day. So just put the plug in, mark it on the agenda, mark it on the calendar. We kick back in tomorrow morning. So. Anybody else? Anybody else?
Isn't there like a mural unveiling or something, or?
Yeah, this afternoon.
Do you want to go?
Thank you. So first, let me thank all the scientists up here. Thank you so much. First, at 5 o'clock, we're going to have the opening reception at Granada Theater, and there's going to be Alpine Runs on Texas mural unveiling. So please, you're all invited, and I hope to see you there at 5 o'clock. If you don't know where it is, it's 207 Holland Avenue. It's about a 5-minute drive from here. Everything is about a 5-minute drive from here. So thank you very much for coming. Thanks again.